Well, welcome back to this YouTube channel. So in this lesson, we're looking at the concept of quartiles, deciles, and percentiles. Right. Of course, percentiles from the word percentage. So it's just a value that divides a data set into 100 equal parts. Yeah. And then deciles, 10. Like decagon, a shape with 10 sides. So deciles are numbers of values. So let me say they are values that divide the data set into 10 equal parts. And then quartiles are values that divide the data set into 4 equal parts. So there are things like first quartile, second quartile, third quartile, fourth quartile, right? Since the whole thing is divided into 4 equal parts. Then for deciles, you have your first decile, second decile, third decile, on and on. And for percentile too, your 10th percentile, 20th percentile, 30th percentile, 40th percentile, on and on like that. Okay, so we'll be looking at the data that we used for chicken, I think a kilogram that we used in the previous lesson to illustrate how the concept of deciles, quartiles, and all of that work. Now, remember the formula of the median of a group data. So we had lower class boundary of the median class equals into brackets n over 2 minus the cumulative frequency before the median class divided by the frequency of the median class and multiplied by the class size. Alright, so this median divides the number into 2 equal parts. So that's why you have n over 2 here. But if we look at quartiles, so quartiles is going to be Li plus a constant k n over 4 minus cumulative frequency before the quartile class, which is a q over frequency of the quartile class and multiplied by c. Alright, so if you're looking at the first quartile, for example, then this is going to be 1n over 4. If you were to look at like kn over 4 for first quartile, you'll be having 1n over 4, which is same as n over 4. Same is true for the second quartile, that'll be 2n over 4, which is same as n over 2. So in some textbook, you just see n over 2 for second quartile, like this how it was gotten 2 here, 1, 2 here, 2. And the third quartile, you'll be having 3n over 4, right? And then first quartile is just going to give you n. Just going to give you n, right? So usually we never say anything about fourth quartile at all, right? At the end of the day in your textbooks. So and then there are things like interquartile range. So if you ask calculate the interquartile range, so interquartile range is just q the third quartile minus the first quartile equals to your interquartile range. But if it was semi-interquartile range, so that means you are going to this same thing divided by 2 to get your semi-interquartile range. Okay, now let's continue. Since this is divided into 4 equal parts, so the second quartile is same as the median. But if you look at it, look at the second quartile, q2 2n over 4, and this is giving n over 2. N over 2 here is also it's also the same thing as the median in this place. So if you remember in one of the lessons when we just started the time we started the measure of central tendency, so I was making you to understand that the second quartile, the 50th percentile, the 50 deciles, they are all equal to the median, and they could also be called measures of central tendency. So look at the formula. N over 2 would have been here, just the same as this. So the CFBQ would have also been the same as the CFBM, and that's about that. So yeah, let's find our cumulative frequency. Let's find that. Cumulative frequency 2, 5, 13, 16, and 18. So if you're looking for your first quartile, the first quartile, so first thing that we have to do is n over 4. Our n here is 18 apparently. So 18 divided by 4 is something like a 4.5. 4.5. So when you have 4.5 here in the cumulative frequency, so it's going to fall under this part, right? It's going to fall under here, 4.5 4.5 is more than 2, but it's not like the next number is more than 4.5. So that means it's going to fall in this place. So what then is the lower class boundary of the first quartile? That's going to be 3.5. Remember, if it was an exam, you'd have to like create a new column for the class boundary, please. But this is not an exam. I'm just trying to let you know. So if you want to apply the formula for the first quartile, you're going to be having 3.5 plus n over 4, which you've already gotten, 4.5, minus the cumulative frequency before the quartile class, before the first quartile, right? Since we're looking for Q1, and then that is going to be equal to 2 divided by frequency of the quartile class is 3, then multiplied by 4. So 3.5 plus 2 over 3 multiplied by 4, which is 8 over 3. So 3.5 plus 8 over 3 should be 2.66, about 2.7. This is approximately 2.7. So 3.5 plus 2.7 equals 6.1. So our first quartile is going to be 6.1. So let's look for our third quartile. Third quartile, that's how I'm going to stop. So we can, okay, I can do something else after that to do. So for our third quartile, so what we have to do, that's 3n over 4. So 3, let's try to figure that out first. 3n, 18 divided by 4. Alright, so 18 over 4 is 4.5. 4.5 multiplied by 3, 4, that's 13.5. 4 times 3 is 12, 3 times 0.5 is 1.5, so 13.5. So we'll come to the cumulative frequency part. So when we do have 13.5, it's more than 13, so it's going to be around here. So our lower class boundary there is going to be 11.5. Once you apply the formula now, so I have 11.5 plus the third quartile, 13.5, minus the cumulative frequency before the third quartile, so minus 5, divided by frequency of the third, well, is it minus 5? 11.5, yeah, this should be 13. 11.5 plus 13.5, then the cumulative frequency before, so that should be 13. 13. Then divided by frequency of the quartile class, since we are here, so this frequency is 3. Then multiply by 4. So 11.5 plus 0.5 times 4 is 2 over 3. So that's 0.67, approximately 0.7. So we add 0.7 to 11.5, that's going to give us approximately 12.2. So 12.2, of course, must fall within this range, right? The third quarter that we get must fall within this range. The first quarter is 6.1. So it's a value between 4 and 7, and this is a value between 12 and 15. So which means that you are probably correct if I've not done any mistake, because I did solve it in my notes actually. So 3n over 4. Again, 18 divided by 4 is 4.5 times 2 is 9, okay, 18. Okay, 4.5 times 3, 4 times 3, 12. Then half times 3.5 times 3, that's 1.5, 13.5. So 11.5 plus 13.5 minus cumulative frequency before quarter 3, 13. Then okay, 0.5 times 4, 2. And that should be it. So what if we are now to find interquartile range? So interquartile range. So it's just it's Q3 minus Q1. So what's Q3? 12.2 minus Q1 is 6.1, and this happens to be 6.1. So I don't know if it's always like that, but it just happens to be that. How can this even be 6.1? This should be 6.2. Should be 6.2. 5 plus 7 is 12, 3 plus 2 is 6, 5, then 6.2. So yeah, we have this minus 6.2, 6.0, so it gets equals to 6. Now, if you are not asked to find the semi-interquartile range, the semi-interquartile range is so semi interquartile range. So it's just equal to Q3 minus Q1, the whole thing divided by 2. So in that case, that will be 6 over 2, which is equal to 3. So with that, we're done with whatever it is I want to learn about quartiles. So next, we move to deciles. So I may not necessarily like illustrate a lot for deciles, but because the whole thing is easy. So as far as deciles are concerned, they divide your data into 10 equal parts. So if you have kn, then this is just going to be 10. So the first decile, that's going to be 1n over 10, which is the same as n over 10. Second decile will be 2n over 10, which is n over 5, right? On and on. Let's look at the fifth decile, which I said is same as the median. Having 5n over 10, and yet it's still going to give you n over 2. So you can see, coming back to this guy, on and on like that. So let's find the first decile and maybe the fifth decile, and then just move on. So for the first decile for D1, it's going to be equal to lower class boundary of the decile class, then plus, okay, don't even waste my time. So let's just do n over 10, 18 divided by 10, and that's going to be 1.8. 18 n over 10, 18 divided by 10 was 1.8. So what's the lower class boundary of that? So this is the first number. That's going to be a negative number. It's going to be a negative number. Anyway, it's okay mathematically. So minus 0.5, then plus that's like our lower class boundary of this class. Minus into bracket 1.8 minus cumulative frequency before D1. There is no CF before D1, so 0. Our frequency of the decile class. Frequency of the decile class is 2, and multiplied by 4. So minus 0.5 plus 1.8 over 2 times 4. So minus 0.5 plus 2 here 1, 2 here 2. So 3.6. And then this is going to give us a 3.1. Okay. So this is going to give us a 3.1. Of course, when we do the class boundary, minus 0.5 to 3.5. Okay, still there. Let's check the solution properly. So n over 10 is 18 over 10. 1.8 minus 0.5 plus 1.8 minus 0. We're going to have times 4. That is correct. 1.8 over 2. 0.9, 0.9 times 4. It's correct. So the fifth decile, the whole thing here is for D1. So D5, just do that will be n over 2. So this button is here, so n over 2, which is 18 over 2, which is 9. So what's lower class boundary there? For 9, that's going to be 7.5. So we are going to be having 7.5 plus 9 minus cumulative frequency before the fifth decile, so which is 5 minus 5 over frequency of the fifth decile class 8 multiplied by 4. 7.5 plus 4 over 8 times 4 equals 9.5. And remember that this followed the normal distribution where the mean median mode was equal to the mean median mode was where they were equal. So that's that about deciles. Now for percentiles, the same thing. Just that for percentiles this is going to be 100, and then your P10. So like 10th percentile, 20th percentile, on and on. So your P10 is going to be 10n over 100, which is of course same as n over 10. So literally your P10 is same as your first decile, right? Your P20 is going to be 20n over 100, same as 1 over 5. So your P20 is still equal to your fifth decile. Is it equal to your fifth decile? No, it's not. What did we erase here? That give us n over 5. Yeah, I think that should be D2, second decile. Then your 50th percentile. So this is going to be 50n over 100, which is still same as, n over 2, same as your, what do you call it now? Same as your, how did I just forget? Same as your median, yeah. So if you want to do that, let's say we want to do our P10. Our P10 should be equivalent to our D1. So P10, also to get this guy out, so we need to do n over 10, which is 1.8, which has been done there before. Lower class boundary of that will be minus 0.5. So literally just writing the whole thing again. 0.5 plus 1.8. Relative frequency before this is 0. 0. It's just the same thing as what is here. 2 times 4. And that's going to give us a 3.1. So P90, because P90 and P10 happens to have significance in statistics. So our P90, it's just like the same way we do like interquartile range, Q3 minus Q1. Like remember, the first quartile, you divide the whole thing into 4, right? So the first one, the third one minus the first one, that's the interquartile range. So here too, 90th 10th percentile, maybe 10th 90th percentile. I think it's 90th 10th percentile or something like that. Right? It's going to be the percentile before the last one, like before 100, so it is 90 minus the percentile that you begin with, so it is 10. So P90 minus P10. The same way you have Q3 minus Q1 out of 4 divisions. So P90 is going to be equal to so that'll be 9n over 10. Is that what it? This is P50, please. So P90, 90n over 100 is equal to 9 over 10n. So this cannot even be divided. 9 over 10n. So yeah. So what's 9 over 10n? N is 18. So 9 to bracket 18 over 10. Okay. So that's 9 times 9 times 2. 9 times 9 is 81. 81 times 2 is 162. 162 divided by 10 is 16.2. Right. So good. So we have 16.2. So what's the lower class boundary there? Where do you have 16.2? 16.2 is going to be around 16.2 is more than 16, so it's going to be around here. Which makes sense because you're almost done with the entire data set, like P90, right? So it's going to be around here. So our lower class boundary for 16.2 is going to be 15.5. So 15.5 plus 16.2 minus cumulative frequency before the 90th percentile, which is 16. Then divided by frequency of the percentile class, which is 2, and multiplied by 4. So I've got 15.5 plus 0.2 over 2 times 4. Now 2, yeah, that's 2. This is 0.4. 15.5 plus 0.4 equals 15.9. Does that make sense? Does that make sense? The class boundary of this guy is 15.5 to 19.5. So 15.9. Alright, so let's check it out again. P90, 9 into bracket 18 over 10. 9 times 9, 81. 81 times 2, 162 divided by 10, 16.2. 16.2 is found. It's more than 16. So 16.2 is around this figure. Okay. At least 15.5 plus open bracket 16.2 minus cumulative frequency before the 90th percentile minus 16. Okay. Over frequency of the 90th percentile, which is 2 times 4. Anyway, but that's it. 2 here 1, 2 here 2. Then 0.2 times 2, that's 0.4. So 15.9. It's okay. So that's going to be our 98th percentile. Then on and on like that. So that's about the whole thing. So I don't think there is any big deal. Remember that in the last lesson we talked about the assumed mean. The formula that we use for assumed mean, it's also a group data. So that formula or the two formulas, right? They are, what you are also going to use for what do you call it now? Your group data. So you see this, yes, you see the same formula. Do you understand? Just that one, the x there, right, is not midpoints. So it's just those different observations that you have. Just the same formula. Do you understand? So get your use the assume mean, then get your x minus a as a deviation, then just continue with the formula. So if you ask calculate the 90th 10th percentile, is it P10 or P10 P90? Let me even be very sure of that now. I solved Q3 for this question. I erased Q3. Yeah, I didn't solve for P. Okay, the assignment here was for you to prove that Q2, D5, and P50 are equal to the median. I think I've done that to a reasonable extent. So there's no point for that assignment again. So the P10, P90 stuff is just going to be your P90 15.9 minus your P10 3.1. So if we are to do P10, I think P90, P10, whatever. So 15.9 minus 3.1 is going to be 12.8. So that's about that. There is no assignment. There is no assignment. Should I give you an assignment for you to practice something? Okay, let me give you an assignment. So the first one, just solve for. I think we did Q. Okay, solve for second quartile, 60th percentile, then 8th decile. Yeah, second quartile. Maybe I should just make this the 6th decile. Okay, and yeah, and that's it. So thank you very much. See you in the next lesson. Bye.